Okay, example 1, divide x cubed minus y cubed by x minus 1. Now, usually what we do when we see missing powers, so obviously there's no x squared, x to the first constant, that kind of thing, and there's no y squared, y to the first, or whatever either. Usually what we do is put zero terms in. The problem is that we don't know how many zero terms to put in. So what I want to do instead of putting zero terms in is just leave space. So x cubed minus y cubed. Leave some space. All right. In the process of division, if y cubed happens to show up in my product, I put that underneath y cubed. Otherwise, I put it in the space. All right? So leave yourself some space, ample space there for other types of things to show up that aren't either x cubes or y cubes to show up. The division process is what it has been in the long division. We take the first object inside divided by the first object outside. That's always what division is when we're doing long division of polynomials. So if I do x to the third divided by x, both positive, gets me a positive x squared. Worry about signs too. Both those are positive, so we get a positive result. I am only dividing by x. All that happens is the power of x drops by 1. Right? I multiply x squared times both things. That gets me x cubed minus x squared y, which is not y cubed, right? So I leave that in my empty space. So again, if this second object happens to be a y cubed object, put it underneath y cubed. Otherwise, put it in the empty space. Okay, after we do the multiplication of the answer times the entire divisor to get the product down here, binomial product, we're going to subtract. Subtraction is changing signs. So x cubed becomes negative, x squared y becomes positive. And in the whole process here, what should happen is this object and this object should be opposite. Positive x cubed, negative x cubed cancel. And then you get whatever you get, which is x squared y. Gap minus y cubed. All right. Then you go through the process again. Because again, we're not expecting a remainder on these. So we go through the process again. Divide first by first. We got a positive x squared y being divided by a positive x, which gives me a plus, and then xy. Again, the power of x drops by 1. The y is not affected by the division. X squared divided by x makes x. Y divided by nothing makes y. Multiply xy times both pieces of the divisor. Positive xy times x makes positive x squared y. Positive xy times negative y makes negative xy squared, which is not y cubed, right? So I'm going to put that in the gap. So xy squared goes here. Again, I need to subtract. Subtraction is changing signs. X squared y becomes negative. Xy squared becomes positive. Positive x squared y minus x squared y being opposites cancel. Xy squared plus nothing makes xy squared. Leave some space, minus y cubed. We're back at the division step again. Xy squared divided by x. We got positive divided by positive makes a positive. X divided by x cancels. Y squared divided by nothing makes y squared. Y squared times x makes xy squared. Y squared times negative y makes negative y cubed, which is matching with that. So notice I put that underneath y cubed. I'm subtracting. Subtraction is changing signs. Xy squared becomes negative. Y cubed becomes positive. Positive xy squared minus xy squared cancels. Negative y cubed plus y cubed also cancels, leaving me a remainder of 0. If that didn't cancel, again, we're not expecting remainders in these, but if that didn't cancel, that would be the remainder. We're out of x's. We're divided by x, so we're going to create a fraction at that point if we try to divide by x. So that would be the remainder, but again, expect them to get a remainder of 0 on these. Remainder of 0 just means that we don't have to write a remainder. No remainder term necessary. That is the entire quotient.